I'm Anil Kumar, and in this video we will see how to utilize the equation of plane in scalar product form. The equation here is: find the equation of plane in scalar product form passing through the point -1, 2, 5 and perpendicular to I plus 5j plus 3k. What is the distance from the plane to the origin? So in this case, we are given a point P, let us say. So the point given to us is -1, 2, 5. So the position vector R, which is OP, can be written as -1, 2, 5. Correct? We are also given the normal. Normal given to us is I, 5j, 3k. That means 1, 5 and 3, right? So that's the normal vector. We can always find the unit vector also in this direction. So the magnitude of this normal vector is square root of 1 square plus 5 square plus 3 square, which is, let me extend this side, square root of 1 plus 25 plus 9, so square root of 35. Okay, so that is the magnitude of this. So that kind of gives you a unit vector also. So let me write down the unit vector here. Unit vector will be the unit vector will be 1, 5, 3 divided by square root of 35. Correct? So that is the information given to us. Now let's read the question once again and relate all these things. Find the equation of a plane in scalar product form passing through this point and perpendicular to the normal vector to the plane, right? What is the distance from the plane to the origin? So first we need to find the equation of the line and then the distance from origin. Okay. Now equation of the line is r dot n equals to d. Now r is the position vector which is given to us. So we write -1, 2, 5 dot n, which is 1, 5, 3. And this is equals to capital D. Let's find this, capital D. So -1, 2 times 5 is 10 plus 5 times 3 is 15 plus. That is equals to D. And that is 24, right? So 24 is equal to D. So the equation, the scalar product, that is the scalar product, right, in the vector form is R dot the normal vector 1, 5, 3 is equal to 24. So that becomes the equation, right? So this is the equation for the plane which is perpendicular to I plus 5j plus 3k and which has a point -1, 2, 3 on it, right? So that is the equation. Now the second part of this question is to find distance from origin, right? So now we'll find distance of the plane from origin. Okay. Now as far as the distance is concerned, we know r dot n unit vector is equals to the distance from the plane, right? So we need to use the unit vector. Now here we have the vector as such, so we'll just change this equation a bit. So we can write this as r dot. Now unit vector will be the vector divided by the magnitude of the vector, right? So what we are doing here is we are replacing this by the magnitude, right, of the vector. Now, so that is to say we have r dot n already written, which is r dot 1, 5, 3 divided by magnitude, which is square root 35. Square root 35. Now this is what we have. Now we know the numerator is such as 24. So we could write this as 24 divided by square root of 35. You get an idea, right? So we know this d is basically equals to r dot unit vector, and the unit vector is the vector divided by its magnitude. And we know the product of these two, the numerator which we have, is given here, right? R dot 153, which is 24. So if I divide that by square root of 35, the magnitude of the normal given to us, we can straight away get the distance, right? So the answer for part B is, that is this part, is that the distance, the plane is 24 square root 35 units from origin, right? So that is how you can get. So let me write down the relation which relates capital D with small d. So capital D is basically, small d is basically capital D divided by the magnitude of vector. Is it okay? Which relates the two. So this is a very important relation, and I hope you understand how it can be applied in different situations. I'm Anil Kumar, and I hope that helps. You can always share and subscribe my videos. Thank you, and all the best.